Okay, these are the Conic Sections notes. This is page 6 and the last page. So let's take a look at example 9. What do we have? We have a circle up top. The numbers in front of the x squared and the y squared are exactly the same. We have an ellipse down below. Number in front of the x squared and the y squared are different. Okay. Let's look at the easiest way maybe to do this, because we look at that, we see x squared and y squared, and we want to maybe multiply the top equation by -3 and then add. And we could do that, and I will do that in a minute, but I also want to point out, because we're not used to doing it, I could solve for x squared and make x squared equals 26 minus y squared, and then go ahead and plug that in to the second equation. Okay. 3 times 26 is 78. Minus 3y squared plus 25y squared equals 100. Now, let me show you why we're not going to get something that looks too terribly different if we just multiply the top equation by -3. When I do that, I'm going to get a -3x squared minus 3y squared equals -78. When I add, I have got 25y squared minus 3y squared, the 3x squared's canceled, equals 100 minus 78, so 22. Basically the same thing we have over here. Okay? So the point here is that you don't want to spend a whole lot of time staring at it and stressing yourself out about what's the right way. Do what you can do. If you get to a point where it doesn't make sense, then change up, right? But don't worry too much. This one's a little different. Y squared equals 1. If I add in the square root, keep in mind I am looking for the y that makes this true. So y could be +1 or y could be -1. I got to keep that in mind when I plug in back in up here. And I'm going to use that first equation. Just because I'd rather not multiply by 3 and by 25 if I don't have to. So let's start with y equals 1. X squared plus 1 squared equals 26. X squared plus 1, x squared equals 25. So we have to consider the same thing. If I want the numbers that make this true, the x's, x could be 5 or -5. That means when y is 1, x could be 5, and when y is 1, x could be -5. Second thing we're going to do is the same thing with y equal -1. I got x squared. I'm going to slide this down so I have see if we can move that. I get x squared plus -1 squared, and you can see what's going on here. X squared plus 1, x squared is 25, and I get, again, x equals 5 or -5. Keep in mind, though, this time, y was -1. We got x was 5. Y was -1. We got x was -5. So keep in mind when you're solving for something that is squared, you may have multiple equations. So let's do this one more time. This would be a great place to hit pause, as riveting as I know these recordings are. Hit pause, try example 10 on your own, and then come back and double check. Okay. This one's set up kind of nice. I am going to just add straight down and get 5x squared equals 5. X squared equals 1. And we're starting this off the same way. Either x equals 1 or x equals -1. And I'm going to set it up that way. If x equals 1, I'm going to go ahead and plug it into the second equation. Let me throw that in here. X squared minus y squared equals -16. So I get 1 squared minus y squared equals -16. 1 minus y squared is -16. Negative y squared, make sure that when you subtract that 1, you don't lose the negative in front of the y. So y squared is 17. Y equals either positive square root of 17 or negative square root of 17. If the homework asks for a decimal, that's fine. I'd rather you leave this as an exact. So leaving it as 1 square root of 17, perfectly fine with me. So when x is 1, y could be square root of 17. When x is 1, y could be negative square root of 17. And we're going to get something that looks awfully similar because when I square -1, I'm going to get the same thing as when I square +1. So from this point on, it's going to look exactly like what we had to the left. So when x is -1, y is the square root of 17. When x is -1, y is negative square root of 17. And there are the 4 solutions, which makes sense. We have an ellipse and a hyperbola. They can intersect in up to 4 places.